在网上搜索激素二字，我看到最多的3个关键词就是毒激素、副作用、慎用。激素真的这么可怕吗？激素类药物、食品对人体的影响到底有多大？本集生命密码将帮助大家打消对激素的恐惧，重新认识激素的力量。
很多人包括我包括我的家人一看到这上面有激素这2个字都不敢用。其实我想让你就是除去人的这种顾虑。
激素是我们人体不可缺少的一种元素，如果说没有激素，我们就没有生长发育，也没有你的生殖，甚至就没有你的生命。激素呢，它有各种各样的激素，有的是管我们生长的有的是管我们的代谢的。当然老百姓所说的这种激素很害怕的就是说变胖，出现骨骼头坏死的叫糖皮质激素，没有必要害怕。糖皮质激素就是从肾上腺这个皮质分泌的，它呢多了之后，它会使我们的血糖升高，使你变胖。但如果说这个肾上腺的激素分泌功能低下，我们就会容易出现低血压，容易出现低血糖它使你变胖有一个特点，它容易出现腹型的肥胖，我们叫中央型的肥胖或者叫苹果型的肥胖。很多的这些男性尤其是这个领导干部就是所谓的啤酒肚，实际上不一定是啤酒，喝多了之后当然就是出现的这么一个肚子的大腹便便，实际上可能跟他的压力有关系。长久的处在一种高压的状态之下，糖皮质激素就把其他的一些脂肪就搬到你的腹部来了同时呢你吃的又多，这个地方就堆积起来，就出现啤酒肚。激素有时候还是很神奇的。
那但是它会有副作用吗？还是这类药我就不能用了吗？
如果说你用的这个剂量是恰当的，疗程也是合适的，它就不会对你有多大一个不好的作用。很多的人，你如果说是糖皮质激素的缺乏，你不去用，最后会有生命的危险。用对你只有你的血压会更稳定，你的抵抗力会更好。所以说不要谈激素舌辩但我们用好激素，激素呢就好像水一样，太多不行了，太少那没有水肯定没有生命啊。
武教授说，对于内分泌科的医生来讲，激素是他们工作中非常重要的工具，医生离不开它，病人也离不开它。
Professor Sadaf Farooqi has been working at the cutting edge of hormone research for more than a decade. She and her team have been studying the role of hormones in obesity. And in this condition, hormones work in a much more surprising way than we ever imagined.
So the first real breakthrough emerged with the discovery of a completely new hormone called leptin, which was first found in mice which were severely obese. And this really paved the way for finding out an entirely new system for how weight is regulated. And this system depends upon the hormone leptin, which is actually made by our fat.
It was a discovery that was entirely unprecedented. A hormone produced not by a gland, but by cells which no one thought had any part in the endocrine system.
And this is not something we had realized before. We didn't know that fat could make hormones. We knew that fat is there to store extra calories. But this was a really important discovery because we learned that fat could make a hormone that circulated in the bloodstream and acted in the brain to control our weight.
Incredibly, with this hormone, our fat cells themselves can control how much we eat by setting up their own feedback loop with the brain. It works like this. Leptin is constantly being produced by our fat cells, and the more fat stores we have in general, the more leptin flows in the blood. This essentially tells our brain that we've eaten enough and we lose our appetite. But where Sadaf's work comes in is when this system doesn't work properly, and for some reason the fat cells don't make leptin. Sadaf is still working to understand all the reasons behind how this can happen. But by figuring out one cause in particular, she has already made a fantastic discovery. Remarkably, a patient's inability to produce leptin can, in some cases, come down to their genes.
A key part of how we discovered the role of the hormone leptin was using genetics. And we were able to look at the DNA of patients and find that they had a mutation or a gene defect that was disrupting the hormone leptin. And this was the cause of their weight problem.
In the rare case that someone has this faulty gene, they will be unable to control their appetite, and so will eat more than their body needs. And this will inevitably mean that they become obese.
Up until that time, most people thought that actually your tendency to gain weight was purely down to self-control. It was purely down to the food you eat and the exercise you do, and there wasn't really any biology involved. Actually, what we showed through the discovery of leptin and its lack in patients is that, in fact, genes can play an important role in controlling our weight, and they do so by affecting our appetite. And leptin is a key regulator of appetite.
It's an incredible discovery that hormones are a key factor in our ability to maintain a healthy weight. And the fact that even a person's appetite can be marshaled by a hormone has given people new hope in the battle against obesity.
That really meant that we could find treatments for those patients, and we were able to give them leptin back, and we did that by giving them injections which they take twice a day. And thankfully, it's worked incredibly well. And now they live entirely normal lives, they are a normal weight, and many of the other health problems that they suffered with have been corrected.
With the simple introduction of leptin, Sadaf has been able to effectively cure obesity in those patients who would otherwise have no control over their weight. It's a striking example of the power of hormones.
萨拉夫教授利用激素帮助肥胖症病人恢复了健康，我们不得不感慨，原来激素在临床上竟然还有如此神奇的作用。那它在人们生活当中又有着怎样的面貌呢？
看过一个新闻说，从奶粉里面会有这种的生长素，这种是好还是不好？就是对于一个小孩来讲，人为的去增加这种东西，
我觉得这个只是一个传说这个应该没有任何的一个依据。2010年吧，曾经说某一个品牌的一个奶粉，一群孩子吃了之后有性早熟，实际上后来发现，它不是说这个奶粉吃了性早熟，是一个正常的一个生理的现象，每一个人都有的，只不过是以前大家都没有关注。后呢，这个媒体报道说吃这个奶粉会出现性早熟，这个家长都回去一看，发现了一大批人都有防发育，就认为跟这个奶粉有关系。实际上你吃其他的奶粉或者你不吃奶粉，都会有这种现象，这就是也闹了一个乌龙。一般说来，就是说这个奶粉它本来是从动物来，它里面就应该有一些天然的一些激素，对吧？但是它的含量是非常非常少，跟你吃母乳一样的。但是如果说加上一些生长素，促进生长的，我个人认为最主要的一个是生长激素。生长激素它是一种蛋白质，它加进去是非常不稳定的，而且还很贵，代价很高。你加一点可能比它这个奶粉的价钱还贵，所以说一般的这个生产厂家不会去做这个亏本的生意。还有一个呢，就是加性激素，这个性激素就会出现性的发育。当然我们前面说的这些乳房的发育是一个生理的现象，我们现在这么多孩子吃了之后，他没有说出现一个第二性征的发育，所以说呢，这个没有任何的依据或者是说数据来说明它。
但是就是说这种性早熟来讲的话，它还不是一个好事吧？
性早熟当然不是一个好的事情。
那如果要避免孩子有这样子的，那我听说过有一个，
第一个的话呢，就是不要太胖，
营养不能过剩。
这我还没准备好，飞机就已经到了，那你就措手不及呀。你就跟正常的孩子不同步了。实际上我们人体，我们说呢，神经系统、内分泌系统对它的调控 很神秘。比如说这个亚洲的孤儿到了欧美，他去抚养，他就会容易出现性早熟。所以说这个还有一些情绪很重要，还有一些性早熟是实际上这些孩子的话是他出生啊，他自身的先天的因素。就是说这个孩子出生下来他的体重很低啊，在5斤以内，他将来就容易性早熟，也容易得糖尿病。倒不一定说是吃了奶粉或者是怎么样。
反正这个性早熟的话，也应该是他自身的这个分泌系统有问题，就是有些不平衡的地方。
对。
回顾内分泌学的发展史，我们看到科学家们使用激素治疗各种疑难杂症，同时也有人为了抓住大众对永葆青春的渴求心理，掀起了所谓器官疗法的医学潮流。
This extraordinary advertisement from the early 20th century claims to have found the power to rejuvenate old men.
Populous. Hormones of 2 testicles. This is so funny.
The story of this ridiculous claim and its surprising consequences begins in 1889 in one of the most august institutions in Europe, the Academy of Sciences in Paris. At a very formal occasion, a serious audience came to hear the announcement of one Charles Edward Brown-Séquard. What Brown-Séquard announced was a truly unbelievable experiment. He said he had prepared a concoction of the following 3 ingredients:
blood of the testicular veins, semen, and juice extracted from a testicle, crushed immediately after it has been taken from a dog or a guinea pig.
The resulting blood and semen mixture he injected into himself. This is what he told his astonished audience, that he'd more strength and stamina, his concentration powers had improved, and as well, his mental energy was considerably better.
Apparently, there was shocked silence in the audience. But with an average age of 71, you can just imagine them thinking, oh my goodness, that would be good. This had the potential to be the elixir of life and a possible breakthrough of the century.
The announcement sent the media into a complete frenzy, and with the public demand for this kind of cure-all remedy soaring across the globe, the papers were filled with articles and advertisements about it alike.
Brown-Séquard was headline news throughout the whole world. The press asked, was this a genuine elixir of life?
Of course it wasn't. But it was a call to arms, signalling the start of a period of intense interest in the testicles and other related organs, whose extract people thought could be used for medical purposes.
By tapping into the public thirst for miracle cures, Brown-Séquard created a real phenomenon. This was called organotherapy and involved the injection of various glands into people, often with very little scientific evidence, to cure various illnesses.
没有人能够重复塞加尔的实验，因为他所宣称的改良效果只不过是一种安慰剂在起作用。
因为动物的睾丸里面雄性激素的含量很低很低的，你吃一箩筐还不如现在一粒药那含量多。但是正因为它的谎报军情，引起了全世界这个领域很关注的科学家的深入的研究，把它在巴黎科学院演讲的那一天，也就是1889年的6月1号，就定为内分泌学的诞辰之日。我们追求长生不老永远有活力，这对内分泌学实际上有很大的一个贡献。 当时有目的、有追求的时候，你才去努力，
有动力啊，
有动力嘛，
探索的动力。我看到过一个新闻，这个性激素，就雌性激素，也可以用来美容，可以让它更年轻。
你说的有一定的道理，但不一定完全的全面。实际上你看男人跟女人的皮肤是不一样的，对吧？男人显得粗糙一点、粗犷一点嘛。这个女人就是细皮嫩肉。这就跟雌性激素有关系。雌性激素呢，使这个细胞里面的水分的含量比较多。所以说呢，它青春发育的时候，这个女孩子就皮肤变得特别的好细嫩。到了这个更年期，女性不就没有雌激素了吗？雌激素就很少了。如果我们补充一点适当量的雌激素的话，它就可以使她的这个皮肤的老化呀，以及这个整个生殖系统的衰退，甚至对她的骨头的密度，对于他的心情、情绪都会有一些好转，但是呢，不能补得太多，要注意补充多了之后，可能对于雌激素的另外一方面，比如说这个乳腺癌，还有一个就是宫颈癌这方面的问题。但是如果说适量的话，可能是会对人体是会有好处。那么对于一个男性来说，实际上男性随着年龄的增大，他的雄性激素也会逐渐的减少。只不过呢，它就跟下山坡一样，不像女性是断崖式的、蹦极式的。它每年它的这个雄性的激素大概下降1%，比如说你过了30年、40年，对吧？那么你下降30%是回头望的时候，我也下降了很多。尤其是有些人，在这个下山的过程当中，因为疾病或者生活方式不好，就连爬带滚就下来了。他也可能会感受到跟女性一样的更年期的症状，一个一个的冒。
The days of brown Sicard may have been long behind us, but the hope for a secret to eternal youth remained. Q, one of the most bizarre fads in medical history.
All across Europe and indeed the world, men began to subject themselves to an operation which was extremely perverse. What they wanted to do was to recapture their youth. This is the Prater in Vienna, the oldest amusement park in the world. Surprisingly, in the early 20th century, it was the site of a laboratory which carried out quite remarkable experiments.
The Biological Research Institute on the grounds of this park also went by the nickname of the Vivarium. And it was here that physiologist Eugene Steinack developed a procedure which he claimed could reverse the aging process.
This lab was particularly interested in changing the body's natural processes.
Steinack proposed a very similar technique to the one Banting had used to obtain insulin in the pancreas, tying off the duct from a gland to isolate one particular hormone within. This time, however, he wanted to isolate the male hormone testosterone, and for that, he had a very different organ in mind.
Steinack's procedure was to tie off the tube carrying the sperm, in modern parlance a vasectomy. What he thought would happen was that this would create more room for the hormone-producing cells in the testis, and this would give his patients more vigor.
Hard as it is to believe, the Steinack was a sensation, with people flocking to have it done on themselves, including some rather high-profile patients. Among them was the famous poet William Butler Yeats.
At 69, Yeats was in poor health and really quite depressed, and he had writer's block. But after the procedure, he noticed a huge increase in his creative powers, as well as his sexual desire. Interestingly, some people think Yeats wrote his best poetry after the procedure.
A young man in the dark am I, but a wild old man in the light. Then said she to that wild old man, his stout stick under his hand, love to give or to withhold is not at my command.
And it wasn't just his Bertree. A few months after the Steinac, Yates took up with an actress who at 27 was 42 years younger than him. Had Steinac stumbled on the secret of eternal youth? Well, of course he hadn't. And just as with Brown-Séquard, there was no way to reproduce the results he'd claimed. We now know that there's no scientific rationale, and that it was another scientific blind alley. Endocrinology had come a long way by the time we reached Steinac. But his procedure failed because his understanding of how hormones work was far too simplistic.
这个从古至今，我们都，不论是你是富翁还是很贫穷，无论是你很高贵还是很卑贱，大家都希望能够长生不老。
对，赶快教我们点这个延年益寿的方法。
实际上，抗衰老，跟内分泌有很大的这么一个关系。尽管目前我们还没有说有某一种方法，好像一个开关一样，一按这个灯就亮了，就是一给这个药我们就永远健康。或者是说永远不老，这个还做不到。但是我们现在，第一个，我觉得我们的这个人的寿命已经是大大的延长。我最近看到一个新闻，最长的已经到了145岁。那就说人的寿命应该是在120到150岁，应该是有它的科学的依据的。人的衰老实际上有2个很重要的因素。一个呢就是生殖系统的衰老，是它一个很重要的一个标志。女性就不能生育，而男性的生育的能力，他的性功能也会下降。所以说，首先我们认识到的可能这个衰老跟生殖系统有关系，跟男性的、跟女性的性荷尔蒙有关系。
所以我就关心一个，就是这个吃腰子补腰子是不科学的。
那个里面的激素的含量是非常非常之少。现在我们弄得很清楚，性的激素我们可以。比如说这个孩子从来没有发育，通过我们给他补充这种激素，他就很快就发育，就可以模拟正常人。那么一个正常的成年男性，因为各种原因，比如说他的睾丸去掉了，那么我们补充一点这个雄性激素，他有重新恢复他的性功能。如果说你光吃腰子，他肯定是不灵。
我听过一个词叫激素代替疗法。
替代疗法
替代疗法，这是什么意思？
激素替代疗法就是说，我们正常我们的人体应该分泌激素，
对啊，
但是因为某种原因呢，这个激素它分泌的不够，那么我们就要替代它。也就是说，你应该做这个工作，但是你没跟我做下来，我就要换一个人来替代你。
就需要人工的补充
对，比如说你甲状腺的功能低下了，那么我们就用甲状腺的激素去补充。你肾上腺皮质功能低下了，我们就用肾上腺的激素去补充。你如果说不产生性激素，我们就人为的去补充这个性激素，这就是所谓的激素的补充疗法或者替代疗法。
激素代替疗法让我想起武侠小说里常常提到的以毒攻毒，不知道这样的理解是否合适，但毋庸置疑的是，激素早已成为治疗内分泌疾病的关键。
This was the story of the first scintillating discovery which resulted in a successful treatment in endocrinology, and it relates to the thyroid gland in the neck.
The treatment focused on disorders known as myxedema and cretinism. They're in fact similar conditions which can leave sufferers physically and mentally disabled. Fortunately, it is a disease that is completely manageable today, and that's because of the work started by this man.
Victor Horsley was born here in sunny old London into a family of artistic aristocrats. But he had a huge social conscience and was a forcible advocate of free healthcare for all. But for me, his most important work was on the thyroid.
I'm going to explain what he did with the help of some props. These are sheep's thyroids, although when Horsley began his experiments, he used monkeys.
And what Horsley did was to remove the thyroid from some monkeys and showed that they developed changes of myxedema just like humans. Their hair fell out and they became more lethargic.
With this proof, Horsley conclusively demonstrated that myxedema was caused by thyroid deficiency. But beyond this, he then went on to suggest the bold step of transplanting tissue from sheep's thyroid, just like these, into human patients. Others across Europe took up the call, and the practice of transplanting sheep's thyroids into people had some success. But this still wasn't a cure. It was potentially dangerous surgery, and the benefits were short-term.
So the question was, how do we make that into a treatment?
It actually took the work of one of Horsley's students, George Murray, to solve this problem in a highly unusual way.
Murray's solution was to cut the thyroid up into tiny little bits, put them in carbolic acid, stopper them overnight, and then use a common or garden handkerchief. And he used this handkerchief to strain these bits and produce what he described as pink thyroid juice.
This, in some ways, was a revolution. It meant that there was a cheap, effective way of treating these conditions of myxedema and what resulted from cretinism. And it was cheap because he obtained these thyroid glands from the abattoir.
但是这个所谓补充，就是缺多少我们补多少，要生理性的替代，生理性的补充。
但过量的话，
就会出现另外一个极端了。所以说呢，这个太多和太少都不好。
This is a vial of human insulin. It's a hormone, probably the best known hormone of them all. Without it, you develop diabetes. And although that's treatable now, before the discovery of insulin, diabetes was a death sentence.
For children who don't make the hormone insulin, sugar that would otherwise be absorbed as energy passed straight through their body into their urine. This is why the disease is called diabetes. The most common form, diabetes mellitus, literally means a sweet fountain because the urine of a sufferer tastes sweet. Without the ability to store this vital energy, the child slowly wasted away to nothing and never survived beyond their teens. It was incredibly difficult to find a cure to diabetes, even though there was evidence that one organ in particular, the pancreas, might be at the root of it.
In the late 19th century, a couple of German physiologists and clinicians removed the pancreas from dogs and showed that they got diabetes. Now, this led the way to identifying the pancreas as the source of raising blood sugar levels, i.e. becoming diabetic.
And it's an amazing organ because it has two main functions. One is to produce digestive juices which enter the stomach through the pancreatic duct there. And the other is to produce insulin, which controls sugar levels.
But the trouble with the pancreas is that actually most of the pancreas is made up of cells that secrete digestive enzymes. So if you'd have just mashed up the pancreas, there would have been virtually no insulin in it. All it would have been, in fact, digestive juices.
So who was the genius to crack this problem and earn what was the first Nobel Prize in endocrinology? Frederick Banting was in fact the unlikeliest of medical pioneers. He certainly didn't hit on his revolutionary cure for diabetes while working in a well-funded lab. Rather, he was a failing GP in Ontario in Canada.
He was heavily in debt and would subsidize his income by giving lectures to medical students. And yet, he was responsible for one of the most sensational and dramatic discoveries in the whole of endocrinology.
During his research for one of these lectures, he just happened to come across an article in the little-known publication Surgery, Gynecology and Obstetrics. This referred to the possibility of stopping the digestive function of the pancreas, effectively killing off the enzymes and just leaving the hormone-producing cells to do their work.
He spent the day slogging over his notes, thinking how the body controls sugar and, in particular, how the pancreas deals with it.
He went to bed with these thoughts still running through his mind and woke quite suddenly with a surprising revelation.
And this was Frederick Banting's eureka moment. And these are the words of a note he wrote in the middle of the night. He said, diabetes, spelt wrong. He was an appalling speller, apparently, but it was the middle of the night. Ligate the pancreatic ducts of dogs. Keep dogs alive till the atheni degenerate, leaving the islets. Try to isolate the internal secretion of these to relieve glycosuria. You need to be a doctor to understand that. But these were the first steps in the cure to diabetes.
He suddenly thought, if I tie off the duct that produces all these digestive enzymes from the pancreas, perhaps they might degenerate, and I could therefore isolate the few cells or islets that produce insulin and thereby produce an insulin supplement.
What Banting did was to operate on dogs and surgically tie off the pancreatic duct there. He kept them alive for 6 weeks, and at the end of that time, the digestive enzyme cells had died, and he was essentially left with a pancreas that was just producing insulin.
Amazingly, when trialled on animals, extract from this dog pancreas proved Banting's theory was right. And by January 1922, he was ready to see whether the same extract would work on humans.
Leonard Thompson had been a diabetic from a very early age. And in 1921, when he was 14, he was admitted to Toronto General Hospital, days away from death. He looked so thin, some people thought he was a famine victim. He was pale, his hair was falling out, and he smelt of acetone, characteristic of diabetes. And it was at that stage that he and his father agreed to have Banting's new experimental treatment containing insulin of what was described as thick, brown muck.
After a little refinement, this so-called muck, still made from dog's pancreas, gave Thompson a whole new lease of life.
And here's a picture of Leonard Thompson. It's after he started treatment with insulin, and he should have been dead. But happily, he was the first patient to be successfully treated, and it's wonderful because I've never seen a picture of Leonard Thompson before.
Well, it's fascinating, really, because we've come from understanding what the classical endocrine glands were, i.e. from Brown-Séquard and everyone mashing up a few glands, to realizing that actually most of our body now produces hormones. And I think in the future, the discovery of new hormones is going to be absolutely vast.
接着为您播出台湾名嘴会。